Hello, welcome back to Learn Physics. In today's video, we are going to continue with our motion in a plane. Okay, so in last video, we discussed about the magnitude and direction of resultant of two vectors. Isn't it? And so the vector representation, how we will be representing a vector in vector form, all the kinematic equations, all those things we were learning, isn't it? So in that position vector, how we are representing the position vector, if it is in an xy plane, how we will represent? Yes, xi cap. What is this I cap? Is the unit vector along x-axis plus yj cap. Okay, if it is in a three-dimensional way, how we can represent? R equals xi cap plus yj cap plus zk cap. This is how we will be representing the position vector. This is the representation of position vector. Now we are going to find out how we will be representing the velocity vector. Velocity means how we will be finding out the velocity. Velocity, if we have position with us, how we can find out the velocity? Velocity will be equal to V equals dr by dt. Are you remembering the instantaneous velocity, how we took? Yes, V equals limit delta t tends to 0, delta r by delta t, that is equal to dr by dt. Remembering, right? This one we will be representing as in a vector form. Okay, V equals dr by dt. Then as like this x, y, z axis, how we can represent? V equals, if it is in a three-dimensional way, we can represent it as dx by dt into I cap plus dy by dt into j cap plus dz by dt into k cap. This is the formula. How we are applying this formula today while we are doing the numericals, I will tell you. Okay, so understood how we are representing change in x coordinate plus into I cap plus change in y coordinate with respect to time plus change in z coordinate with respect to time into k cap. So each term we should find out the velocity. Okay, so these are the position for each coordinate, isn't it? So we are finding out the position velocity vector for each coordinate and finding out the resultant. Okay, so the next is how we can represent the acceleration. Acceleration, how we can represent? See, yes, acceleration A equals dv by dt, change in velocity with respect to time, that is dv by dt. This is the acceleration. So acceleration in x, y, z axis, how we will represent? So for representing in x, y, z term, it is difficult. So I am rewriting this dx by dt means velocity along x axis into I cap. This is velocity along y axis into j cap plus velocity along z axis into k cap. Isn't it? So here we are representing. So why we are not giving this vector symbol for Vx? Because I cap is there to represent the vector. Isn't it? So we are representing the magnitude alone. So A equals, how we can represent this one? dvx by dt. Each term with respect to time we should differentiate. Okay, the same way into I cap plus dvy by dt into j cap plus dvz by dt into k cap. This is how we will be representing. Or in a short form, if we want to represent, how we can represent? What is dvx by dt means? It is acceleration along x-axis into a cap, acceleration along y cap, y-axis into j cap plus acceleration of z-axis into k cap. This is how we will be representing the vectors. So if we are representing the vector like this, how we will find out the magnitude of all these vectors, position, velocity and acceleration magnitude, how we will be representing? Last class we learned, are you remembering? How is it? Yes, R equals, magnitude of R equals root of x square plus y square plus z square. So magnitude of V will be equal to root of Vx square plus Vy square plus Vz square. Magnitude of acceleration will be written as root of Ax square plus Ay square plus Az square. Okay, clear this? Okay, this is how we will be representing the acceleration. Okay, clear for you? Now I'll tell you how to find out this dvx by dt or dx by dt, that and all how we are going to find out. Okay, now we are going to find out how we can represent this, how we can find out this dx by dt or dv by dt, dx, dv, a by, so all those things how we will be finding out. Okay, so for that change in position with respect to dx by dt or dv by dt or dA by dt. What is that? Change in position along x-axis with respect to time. Change in velocity with respect to a small interval of time t dt. Change in acceleration with respect to time. So all the acceleration change we are not finding, we don't have acceleration change. So these two we have, isn't it? So how we can find out? For this, finding out this one, we are using a mathematical tool called differentiation. Differentiation means, what is meant by differentiation? So differentiation, how we can do the differentiation? Differentiation means, see, I am finding out the differentiation of a function with respect to x. D by dx of x to the power n. Okay, d by dx means that is differentiation with respect to x. For which function I am differentiating? X to the power n I am differentiating. Okay, so this function should be there should be a factor which is depending on x. Okay, then only we can differentiate. Okay, so equal to n into x to the power n minus 1. This is the formula. D by dx of x to the power n equals n into x to the power n minus 1. Okay, so for example, if I am finding out d by dx of x square, how I can do? Here d by dx of x square. So in place of n, here 2 is there. So 2 into x to the power 2 minus 1. That is 2x will be the value which we will be getting after differentiation. Suppose I need to differentiate a function like d by dx of 3x plus 2x square plus 1. So in this case we should differentiate each term separately by keeping the constants outside. Okay, so here listen here, d by dx of 3x plus 2x square plus 1. How I can differentiate this one? Actually the correct way of representation is first square term and then next term. Okay, so d by dx of 3x, each term separately we should differentiate. Dx of 2x square plus d by dx of 1. Okay, so here d by dx of 3x means 3 is a constant, that I am taking it outside. What is dx by dx? Plus 2 into d by dx of x square plus d by dx of, see, 1. 1 only we will be getting, isn't it? So differential of a constant will be equal to 0. Differential of dx with respect to x will be 1. So this is 1. Here you differentiate and tell me, yes, n into 2 into x to the power 2 minus 1 plus 0. So you will get it as 3 plus 4x will be the answer, because differential of a constant will be equal to 0. So this is how we will be differentiating the things. So this is 100% purely mathematical only. But what is this actually differentiation? Which cases we are using? Suppose if we have a large value, we need to find out a value in between a small time interval. Then we will use differentiation. So for converting a bigger value to a smaller value, we will be using differentiation. Small change in displacement with respect to time. In a small interval of time, what is the change? Dx, d and delta, all those things, all those terms usually we will use it for finding out the smaller values. Okay, so dx by dt. So change in velocity in a small interval of time, delta t. So we have a big value with us and we need to find out the smaller value. What will happen? That is called a differentiation. Okay, clear? This is also, while we are doing the numerical, you will understand it more clearly. Okay, now we will go do some numericals relating to that one. That is in page number 87 of your textbook. In page number 87, 20th question. Okay, the position of a particle is given by vector r equals 3 t I cap minus 2t square j cap plus 4 k cap meters. Okay, where t is in second and the coefficients have the proper units for r to be in meters. Find velocity and acceleration of the particle. What is the magnitude and direction of velocity of the particle at t equals 2 seconds. So first one is find the velocity and acceleration of the particle. We should find out the velocity and then find out the acceleration. These two things we should find out. How we can, if we have the position vector with us, how we can find out the velocity? Velocity is equal to dr by dt. That is d by dt of, what is r? 3t I cap minus 2t square j cap plus 4k. Okay, now what we should do? 3. We can take each term we should differentiate. So we can take the constant outside that one. dt by dt I cap minus 2 into 2, we can take it outside, d by dt of t square j cap plus 4 into dk by dt. Okay, so here what is dt by dt? That is 1. So 3 I cap minus 2 into d by dt of t square. T square, how we will differentiate as per equation? N into x to the power n minus 1. So 2 into t to the power 2 minus 1 into j cap plus 4 into 1, simply if we are writing down k, what is the meaning of that? 1 into k cap. So d by dt of 1 is 0. The differential of a constant is equal to 0. So we are getting it as 3 I cap minus 4 t to the power 2 minus 1 is 1. 3 I cap minus 4t j cap. This is the velocity vector. Okay, clear? Now we are going to find out the acceleration. So acceleration equals, how we can find out the acceleration? Differentiate the velocity vector, dv by dt. So what is differential of velocity? What is the velocity here? 3I cap minus 4t j cap. Okay, differential of a constant is equal to 0. So which will be existing? Minus 4 into dt by dt into j cap. So what is the answer for this one? Minus 4 j cap. So dt by dt, how we are getting it as 1? That one you know, right? It's not by cancelling. Don't think like that, because d by dt of t to the power 1, that means 1 into t to the power 1 minus 1. So t minus 1 into t to the power 0. With this one you will get it as 1. Okay, this is how we are getting it as 1. Okay, don't think we are cancelling both the things and writing, and we are just differentiating the t to the power 1 and will be getting the answer as 1. Okay, clear? So first part is over. Second part, find velocity and acceleration of the particle. What is the magnitude and direction of velocity of the particle at t equals 2 seconds? So magnitude and direction of the velocity of the particle at t equals 2 seconds. So second one is t equals 2 seconds. What is the velocity at t equals 2 seconds? So velocity is given as 3I minus 4 t j cap. So instead of t, what we can substitute? 2 into j cap. So 3I cap minus 8j cap. This will be the velocity. How we can find out the magnitude of velocity? Magnitude of velocity is equal to root of vx square plus vy square. So what is vx here? 3 square 9 and vy is 8 square 64. So you will get it as root 73. Okay. Now how we can find out the direction of this velocity vector? How we can find out? See, I'll do it here. See, velocity is a vector representing in a plane like this, isn't it? X coordinate. This is v, and this is x coordinate vx, and this is y coordinate vy. If we have theta with us, what will be tan theta? Tan theta will be equal to opposite side divided by adjacent side. So what is theta here? Tan inverse vy by vx. Okay, so what is the value of tan inverse? What is vy here? 8 vy into j cap, which has j cap, that will be y coordinate. So it is minus 8 divided by, what is vx here? 3. Tan inverse minus 8 by 3. So that is the value of direction, okay, from the x-axis. Clear? This is how we will be finding out the values. Clear now? So shall we move to the next one? So next we are going to do 12th question from 86, page number 86, 12th question. Okay, 12th question is, rain is falling vertically with a speed of 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. What is the direction in which she should hold her umbrella? Okay, so rain is falling vertically with a speed of 30 meters per second. So rain is falling like this, 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. So she is riding the bicycle from north to south. Okay, this is north and this is south. So velocity of the woman is given by is 10 meters per second. Okay, so how we can find it? What is the direction in which she should hold her umbrella? In both are moving, rain also moving and women also moving. So in which direction she should hold her umbrella? So rain is coming down, both are in motion. Then in which direction we should hold the umbrella? We should find the direction of the resultant velocity and should hold the umbrella. She is moving from here to here, isn't it? So this is VW. This is the motion of the rain. This is how rain is falling. So in which direction she should hold the umbrella? She should hold the umbrella in the direction of relative velocity. So this is rain and she is moving like this, VW. Okay, so in which direction she should hold her umbrella? Yes, she should hold, we can relate in the direction of the relative velocity. Relative velocity means VR minus VW. So we should find VR rain with respect to W. See, so she should hold her umbrella in the direction of VR minus VW. So how we can find out VR minus VW? This is VR plus VW only we will be getting. See, as per, so we can find out VR plus minus VW. So this is VR and this is minus VW. Now you can find out the resultant. Okay, then only we will be getting VR minus VW, isn't it? Resultant will be in this direction, that is, but the direction will be like this. So rain is falling in this direction towards or on her. So she should hold her umbrella just opposite direction, isn't it? If rain is falling like this, she should hold the umbrella in the opposite direction. So this is how she should hold the umbrella. Clear? So this is by vector method we are finding out. So rain is falling like this. She is going from north to south direction. So while she is moving from north to south direction, see, the rain is falling like this. So in which direction she should hold the umbrella? In the direction of relative velocity. How we can find out the relative velocity? VR minus VW. As per vector method, how we can find out the resultant velocity? Direction only we need to find out, isn't it? Magnitude no need. So magnitude means we can just substitute and find out the values. Here we should, in which direction she should hold her umbrella. So the direction is required. For that we require the vector method. So here I am using the triangle law of vector addition taken in order. So it should be the reverse direction. In the order means it will go in the upward direction. Reverse direction will be the resultant, that is VR minus VW. So rain is falling in this direction and she should hold her umbrella opposite direction. Now, so the rest of the things we can find out, right? So VR equals 30 meter per second. VW equals 10 meter per second. So she should hold the umbrella in this direction. In this direction means how we can write down that direction? With respect to the rain, she should hold the umbrella in this theta angle. So how we can find out this theta? If this is theta, this also will be theta, isn't it? So we can find out tan theta. Tan theta will be equal to opposite side divided by adjacent side. So theta will be equal to tan inverse 1 by 3. Okay, clear? This is how we will be finding out the direction. Okay, so shall we move to the next question? So the next one is 13th one. A man can swim with a speed of, so velocity of the man is given as 4 km per hour. And the width of the river is given as width of river equals 1 kilometer. And velocity of the river is given as 3 km per hour. He makes his strokes normal to the river current. He is going just normal to the river current. How long does he take to cross the river? Then if he is going normal, how long he will take? Yes, T equals distance traveled divided by velocity of the man. So distance traveled is 1, velocity of the man is 4, 1 by 4 hours he will take. Okay, and then next question is, how far down the river does he go when he reaches the other bank? While he is reaching the other side of the river, how long he will take? So other side of the river, while he is reaching the other side, see here velocity, that's how long he, so here we should find out the distance traveled. Okay, how far down the river he will go when he reaches the other bank. So because of this river velocity only he is going down the river, isn't it? So in 1/4 hours, because of the velocity of the rain, how far he would have traveled? 3/4 kilometers. 3/4 kilometers means 0.75, that is 750 meters. He will be traveling 750 meters because of the river velocity. Okay, clear now? So the same kind two questions are here in 14th one and 22nd one. Both the questions you do it as a homework. Okay, in next class, while I am starting, before I start this class, I'll discuss those things. Okay, clear all of you? So I am winding up for today. Hope all of you understood all those things. If you like the channel, please don't forget to subscribe, and don't forget about the homework, that is 14th one and 21st one. Okay, 21st one and 14th one are the homework. Please try to do that. Okay, thank you for watching. Bye.